Okay, so we are going to do 7.2 in college algebra, systems with three variables. We've seen 7.1, very similar idea, but now we're just have an extra variable. Our first question is, we need a test to see if 3, -2, and 1 works. And just like with two systems variables, we just write in 3 plus -2, oops, not a comma. Now let me go back. 3 plus -2 plus 1, does that equal 2? That's our question. And then we do the next one. It's 6 times 3 minus 4 times -2 plus 5 times 1, does that equal 31? And then we're going to say does 5 times 3 plus 2 times -2 plus 2 times 1, does that equal 13? All right, we're going to test all these. Well, let's see here. 3 minus 2 is 1 plus, so this one's good. We have 18 plus, because that's a negative times a negative, 8 plus 5. So let's see here. 18 plus 8 is 26 plus 5 is 31. So yes, that is good as well. 5 times 3 is 15. This is going to be minus 4 plus 2. And yes, that's 13. So that is a correct solution. So now we got, so I will say the easiest way to solve all these is try to do elimination. Yes, you can do substitution if you really want to, but it just starts getting really long and big. So really we want to do, try to eliminate if we can. And so really you just need to look through them. So if I notice, got x, -x, 2x, I have a negative x here. This can cancel out this x up here. I'm going to look at my y. So I got 2y, 3y, 5y. None of them really cancel if I add them. And the same thing with z's. Nothing we're just going to do. So what I'm going to do first is I'm first going to do r1 plus r2. So x minus x, it cancels out. -2y plus 3y, that gives me a y. And then 3z minus z gives me a positive 2z. And 9 plus a -6 gives me 3. Now, I need to get rid of this 2x. I'm going to use this -x, but before I do that, I have to say I'm going to multiply row 2 by 2, and then I'm going to do by 3. So if I multiply this by 2, this cancels. Multiply this by just gives me 6y. 6y plus -5y just gives me a y. If I multiply this -z by 2, it gives me -2z plus 5z will give me 3z. Then if I multiply this -6 by 2, which would give me -12, add them together, that gives me, so -12 plus 17 is 5. So now I have two new equations, y plus 2z equals 3 and y plus 3z equals 5. Now the nice thing is that I see that the y's are the same, so if I wanted to, I could do subtraction, but again, I don't particularly like subtraction. What I'm going to do is I'm going to do a negative r3 plus an r2. Oh, let's redo that. Let's do r2 and r3. So negative y plus y gives me 0. Negative 2z gives me -2z plus a 3z gives me z. -3, so negative times 3 is -3, plus 5 gives me 2. So now I have z is equal to 2. And I just start going backwards. First I go take this z and I'm going to put it in this equation right here, which is going to give me y plus 2 times 2 equals 3. So y is equal to -1. Sorry, let me go back and show you why that is. y plus 4 equals 3. Subtract 4, y is equal to negative 1. Then I'm going to take this one, and z, and I'm just going to go ahead and put it in this first equation and solve for x. So x minus 2 times negative 1, because that's what y is, plus 3 times 2, which that's what z is. It's going to give me x plus 2 plus 6 equals 9. X plus 8 equals 9, and x is equal to 1. So my answer, 1, negative 1, and 2. Go to this next problem. Again, I'm looking to see what can I do, what can I cancel out. And I particularly always like to see if I have positive x, and then I have a negative x. I'm going to use this negative x to cancel everything out. So I'm going to do R2 plus R1 first. So that cancels. This becomes negative y minus 4z equals 7. Now just adding negative x to 5x doesn't cancel it, so I have to multiply that by 5 first and then add it to R3. Now I'm just going to do an extra step here. So I'm going to first do R2 by 5. So it gives me negative 5x plus 10y minus 25z equals 15. There's nothing wrong with doing it like this, because then I'm going to add it to this top one right here, and that's going to give me, so the 5x's cancel. This leaves it with negative 3y minus 12z, and that's going to equal 23. Now I have these to worry about now. A couple things I can do. I could, well, let's just go do with my y's, because this is a 1y, this is a 3y. I do need to make this positive. I like adding, I don't like subtracting. So we're going to make this positive. So let's multiply that by 3 first. So we're going to take this, let me do a different color. So we're going to take this right here, we're going to multiply it by 3. Negative 3. That's going to give us a positive, this is my new R1, it's positive 3y plus 12z is equal to negative 21. And we're going to add it to negative 3y minus 12z equals 23. Now we're going to add those. Cancel, leaves this with 0 is equal to 2. Well, that doesn't work. So there are no solutions. Now we're going to look over here. Go back to the black color. And let's see, what do I want to do? How about, I'm going to take this, so this is my R3, R2, R1. I am going to take this one down here, I'm going to take negative 2, and I'm going to multiply R3 by that. So it gives me negative 2x plus 2y minus 2z, and this still equals 0. Okay, now I'm going to add, so I'm going to add this to R1, add to R1, R1 was 2x plus y minus 3z equals 0. When we do this, this gives me 3y minus 5z equals 0. Okay, now I'm going to take the same R3 and I'm going to multiply that by negative 4 instead. It's going to give me negative 4x minus 8y. Let's make sure there's a minus, not minus 8y, plus 4y minus 4z is equal to 0. And now I'm going to add that to my R2, which is 4x plus 2y minus 6z equals 0. This gives me 6y is minus 10z equals 0. Okay, well, I hope you notice something. So those two are the same exact equation. Because if I were to divide this whole thing by 2, this would give me 3y minus 5z is equal to 0. And this would be an infinite solution. What would end up happening, guys, is that let's say we didn't notice that. We would take this problem right here and we'd say, okay, we're gonna need to cancel out my y. So I'm gonna multiply this by negative 2. This gives me negative 6y plus 10z equals 0. And if I were to add this to this, that would give me 0 equals 0. That's hopefully what you're trying to find. Also, there's another idea to where if I were to take, if I wanted to, if I would have taken, let me do this. Let me go to the next page. I'm going to show you another possible what could have happened. Because you could have figured that out in one step if you were lucky. If I was okay, I'm gonna use this 2. I know that if I multiply this by negative 2, that would cancel out, and that would, so if I were to multiply this by negative 2, that would give me negative 4x minus 2y plus 6x. And if I would have added that, oops, then we would have seen it, we would have canceled out to be 0 equals 0. So technically, if I did a certain step one way and cancel everything out to 0 equals 0, I could have automatically have seen that that was an infinite solutions. But eventually you can get there. It doesn't matter. So if you're lucky, you can get that to work. I would have seen that. Hopefully you would have seen, oh look, that's 2 to 4. I can multiply that by 2. Oh wait, that's why I could multiply that by 2. Oh, I could multiply that by 2. So just patterns sometimes can help you out there. That is the gist of 7.2.